In this video, we're going to go over how to rationalize a denominator for a trig function. So I can see that I have some radicals here, and that should, be an alarm for me that I may have to do some rationalization. The sine function is the opposite. A is my reference angle. This is the opposite over the hypotenuse. So I can write that as 3 square root 2 over 5 square root 3. Now, this should raise some alarms because I see that I have a radical in the denominator, and we know we don't like that. That is not good math practice. So we multiply both the numerator and the denominator by the radical that is in the denominator. When I do that, I have the square root of 3 times the square root of 3, which equals 3. So now I have 5 times 3 in my denominator, which is 15. And for my numerator, I know that I can multiply outsides with outsides, insides with insides. So these two values, I have square root 2 and square root 3, they can be multiplied since they are both inside of a radical. And the 3 that is outside stays outside. Once I have a rationalized denominator, my next thought is about simplifying. And I can simplify the 3 and the 15 that are both outside of the radical because they have a common factor of 3. So if I divide numerator and the denominator by 3, I end up 3 divided by 3 is 1, would be 1 times the square root of 6, which is just the same thing as square root 6. And 15 divided by 3 is 5. And this would be the rationalized ratio for the sine of A. I did want to show another one where we may have to do a little bit of extra work. So similarly, we're going to start off by setting up our ratio. And our ratio here is going to be using A again as our reference angle, or square root 8 over 9 square root 3. I'm going to rationalize that denominator by multiplying by the square root of 3. And now I have 9 times 3 in my denominator. At 27. And now I have 4 times the square root of 24, because remember, those insides can multiply with other insides. Once I have that set up, we could look to see if the 4 and 27 share a common factor. They don't. But I really want to get to this square root of 24 because that can be simplified. And so we need to go back and think about how we simplified radicals or square roots. So I'm going to use that perfect square method that we've used before and look for a perfect square that might go into 24. I know that 4 times 6 gets me 24. I know 4 is a perfect square. 6 does not have a perfect square. So the square root of 24 breaks down to 2 square root 6. So instead of writing the problem as 4 square root 24, I'm going to write 4 times 2 square root 6 all over 27. And this will bring me back to the idea of outsides with outsides, insides with insides. 4 times 2 is 8. Square root 6 comes along, and it's still all over 27. And that is the simplified answer.